Hello students, welcome to my YouTube class. Today I am going to discuss chapter 14, electric circuits. Students, electric circuits is a path through which electric current flows. We know to let electric current flow, a path is required. For example, the wires and all that you have in your homes from room to room, it allows the flow of current to take place. So these wires are considered as a path which leads to the flow of electric current. So, in short, we can say the path through which electric current flows is called electric circuit. To form this electric circuit, we require various things which we shall come to learn when we go forward in our discussion. You are all familiar with different types of electrical appliances or electrical things that you have in your homes. For example, the fan, the refrigerator, the television, the computer, the heaters, and all. So all these electrical appliances or the things that you have in your home as fan, electric heaters, refrigerators, and the coolers and all these, it runs out of electric current. So we know that if we try to run all such electrical appliances in the absence of electric current, such appliances do not work at all. If you want to watch television, you will not be able to watch at all because it runs or it works only in the presence of electric current. Other than such electrical appliances, we also have some other appliances that runs on cells. C-E-L-L-S, cells. Here, C-E-L-L-S cells, it doesn't mean the cell that you have learned in your previous class under biology portion. It is the cell that comes under physics part. Okay, here the meaning of this cell is quite different. These cells we can consider as the thing that we find inside the batteries, inside the watches. For example, the toy cars, torches, alarm clocks, mobile phones has got various types of cells. All these appliances, it works on cells. We know the wall clock that we have, you need to have a cell inside it. Then only it will work. The toy car or various types of toys that you have in your homes that your small brothers or sisters used to play with it. It runs out of cells. Likewise, the torches and all also runs out of cells. But nowadays, we use torches which has got charge in it, which can be chargeable. Okay, that means it can work without the cells. But in our olden days, we have been using the torches which runs out of cells only. Okay, nowadays also we have it. You can easily handle appliances that runs on cells. Why? Why we can handle all those appliances that runs out of cells, the torch, the toy car, the alarm clocks and all. Why? Because the energy provided by such cells are not that much as compared to the energy that is provided by the mains that we have in our homes. Okay, because this mains, it provides too much of energy. Okay, if we come to touch any of the electrical appliances, then we may get a bad shock. Sometimes we may die also. But we are easily able to handle the electrical appliances that runs out of cells. Why? We don't get any shock at all because the energy provided by such cells are less as compared to the mains. Okay. But if we come in contact with the electrical socket or live wire which is attached to the mains of our house, then we may get a very bad shock. Okay, because the mains supply a very huge amount of electrical energy, but the cells supply a very small amount of electrical energy. Here, under the cell, we shall learn some other things. We know that these cells, it provides very small amount of electrical energy. It can be used to run alarm clock, there are wall clocks. It can be used to run torches, toy cars, and many other things. Okay, but what lets the cell to work? Let us learn about the cell. You might have seen the batteries. Actually, most commonly we use the term batteries. When we go to the shop to buy the cell, we often used to tell the shopkeeper, give me one pair of battery. But these batteries are again not at all right. We can't say batteries. We should say the cell. Actually, when two or more cells they combine together in series, they form a battery. Okay, at that state, we are supposed to use the word battery. When two or more cells they are joined to in series at that time or connected in series, at that time we should use the term battery. So whenever you go to buy such cells, you always use the correct one, the cell. Okay, so this cell has a simple representation. Okay, there is a simple representation that we find inside a cell. Okay, the zinc container that you might have seen. Sometimes you might have opened the cell, the cover of the cell, and you might have seen what is inside. So if you open the cover of the cell, you might see that it has got a zinc container. Okay, which is the negative terminal of the cell. It is the negative terminal of the cell. Okay, it is sealed on top and covered with a thick paper or a metal sheet to prevent the leakage. Okay, when we open up the cover, thick cover which is made of paper or sometimes with a metal sheet. Okay, at that time we are able to see the zinc container, and this zinc container is the negative terminal of the cell, which helps the cell to prevent from getting leakage. And the metal cap at the top of the cell which is fitted with a carbon rod inside the cell, okay, is the positive terminal of the cell. So the negative terminal of the cell is the zinc container, and the positive terminal of the cell is the metal cap which is fitted with a carbon rod which is found inside the cell. Now we shall learn about the batteries. My dear students, as I have already told you that these batteries are formed when a number of cells are connected in series. Okay. At that time, these batteries are formed. You might see the pictures that you have in your book, page number 136. You can see two pencil batteries. You can see two pencil batteries connected. So at that time when the cells are connected in series, one after another, we can call such cells as batteries. Okay, the figure 14.2, it contains a number of cells connected together inside its casting. The batteries used in cars are also made of many number of cells. Okay, likewise, all these can be termed as batteries. So always use the word battery for the cells when they are connected in series, and always use the word cell when they are not connected in series, when they are found in free state. Now, how do we use a cell? Let us learn how to use a cell. You know that these cells can be used in alarm clocks, it can be used in wall clocks, it can also be used in torches as well as the toy cars or toys and all. So, do you know how to use? You might be thinking, if you have a torchlight, then simply we need to insert the cells inside the torch, then give a switch on the torch will work. It is not like this. We need to know how to use the cells. Okay, inside the torch, we know there are again two different terminals. As the cell has two terminals, the positive and the negative terminal, inside the torch even we have two different terminals, that is the positive and the negative. Okay, so the cells when they are inserted inside the torch in series one after another, okay, at that time what happens when we give a switch, what happens, the negative terminal of the switch, it touches the negative terminal of the cell, and the positive terminal of the bulb, it again touches the positive terminal of the cell. At that time, what happens? A complete loop is formed of, of an electric circuit, and the flow of electrical energy takes place. So, which leads to glow the bulb in a torch. In this way, we are able to use these cells and all. So, as I have told you regarding the bulb, you know that these bulbs that we have inside the torches, these are very small in size. Normally, the bulbs that we are using at present in most of the torches which are chargeable, okay, we can say that such bulbs have got a filament because these are LED bulbs. But other than the LED bulbs, the bulbs which we were using earlier, okay, in the torches and all, if you search your grandfather's torch, you might see that the bulb that is inside, it is quite different as the bulb that you have right at present in as a LED one. Okay, these bulbs that are used in olden days in torches and all, okay, these are very small in size, and inside the bulb, if you see clearly, you can see a small and very thin filament. This thin filament of the bulb is nothing but is a coiled wire-like thing. This filament of the bulb is made of tungsten, and this filament, as it is made of tungsten, it has got a very high melting point, which lets the bulb to glow brighter. Okay, and it also has got two terminals, like the positive and the negative terminal. The metal tip at the base of the bulb is considered as the negative terminal, and the metal case that is surrounded around the bulb is considered as the positive terminal. Okay, so at the time when it is connected inside the torch, the positive terminal of the bulb, it touches the metal tip of the cell, and the negative terminal of the bulb, that is the metal case, it touches the switch which is connected to the, again, with a long strip of metal inside the torch to the negative terminal of the cell. In this way, the bulb, it works when we insert cells inside the torches and give a switch on the torch. The flow of current, electrical energy that takes place to the bulb and leads to glow the bulb. Nextly, we have got the electric circuit. Students, you all have already learned about the circuit. The part which allows the flow of electric current to take place is called electric circuit. So current simply means the flow of electricity. In short, we can say the flow of electricity as current. And electrical current can flow only when there is a closed path for it to travel along. If the electrical circuit does not have any closed path, then the flow of current will not take place at all. In order to let the flow of current to take place in an electric path, what happens? The electric path should have a closed path, okay, to travel. When you connect a bulb to a cell with wires, you create a closed path or a circuit through which the current can flow. You can refer the picture, figure 14.7, flow of current taking place. So, as the wires are connected to the bulb, forming a closed path in the picture, you can see a closed path is formed. So, at that state, the flow of current takes place and the bulb glows. Electric current flows through the wires when the cell's positive terminal of the bulb, and from here to the negative terminal of the cells. So, at the time when the electric current has to flow, it starts flowing from the positive terminal of the cell to the negative terminal of the cell again. In this mode, we can see the flow of current taking place. And the direction of arrows, it shows the direction of current. You can see in picture 14.7. Okay, at the time, if there is any breakup or if the path breaks, then what will happen is that the flow of current will stop at all and the bulb will stop glowing. Now, the next thing that we need to learn is a switch. Sometimes at the time of forming an electrical circuit, we even use a switch. So what is the importance of switch? Let me tell you. We know that if the circuit breaks, the flow of current stops and the bulb stops glowing. So at times, it becomes very important for us to stop the flow of current. So if we have a switch connected with a circuit, then it becomes very easy to stop the flow of current. So these switches that are connected in electric circuits, the switches that you have in your homes, it helps us a lot. At the time when we need a fan to run, we used to give a switch. At the time when we need a bulb to glow, we used to give the switch on the switchboard. Yes, so it becomes very easy for us to handle at all. So this switch, it helps us to stop the flow of current and also to let the flow of current take place in the electric circuit. Okay, the circuit that you have met represents all electric circuits in a simple sort of way. It has a source of current, a device which uses the current, and the wires through which the current can flow. There is just one problem. Once you complete or close the circuit and the bulb glows, then the only way you can turn off the bulb is by what? Disconnecting one of the wires. If you don't have any switches connected with the circuit, then the only way to stop the flow of current is to disconnect the wires from the circuit. But instead, if we have a switch, it becomes very convenient and easy for us to stop the flow of current. It's a device for opening and closing an electric circuit. In short, we can say a switch is a device that helps in opening and closing an electric circuit. It has also two terminals to which the wires can be connected. When the switch is on, a metal strip inside it touches both the terminals to complete the electric part between them. Okay, inside the switch we find a metal strip. So when we switch on, the metal strip, it completes or it covers up both the terminals and lets the flow of current to take place. And at the time when we switch off, the metal terminal that is found inside the switch, it gets separated and lets the current to stop. In this way, a switch works. And these switches are of different shapes and sizes, okay, which you might have seen in your homes. Our next topic is regarding the electric circuit of a torch. Students, if you have torches in your home, then sometimes you open the torch and try to observe the things that you find inside the torches. You can see the picture that is given in page number 139, figure 14.11. Okay. So even the torches that you have, the electric circuits of a torch, okay, also has two terminals. The negative terminal of the cell label 1, it presses against the spring at the base of the torch, and the positive terminal of the cell 2 presses against the metal tip at the base of the bulb. It also has the two terminals as the negative terminal and the positive terminal. Okay, the negative terminal of the cell labeled 1, it presses against the spring at the base of the torch, and the positive terminal of the cell, it presses at the metal tip at the base of the bulb. That means when we press on the bulb, what happens? Switch on the bulb. What happens is that the flow of current takes place from the positive to the negative terminal of the cell. So what happens is that we find a metal strip inside the torch, and this metal strip inside the torch, which is connected to the switch, okay, it runs almost at the base of the torch connected with a spring, which is considered as the negative terminal, and the metal strip which is connected at the positive terminal of the cell, that is the base of the bulb, okay, is considered as a positive terminal. There are three metal strips that we find in a torch labeled as A, B and C. Okay, labeled A is connected with the metal case of the bulb. That means the metal strip which is found inside the bulb, which is labeled as A, is connected to the metal case of the bulb, and the metal strip which is labeled as B is connected with a spring, and the metal strip which is labeled as C is a part of the switch. So all these three metal strips togetherly, it lets the torch to work. At the time when we give a switch on the torch, the flow of current or the energy takes place from the cells to the bulb and lets the bulb to glow. Lastly, we shall learn about the conductors and the insulators. Conductors are those materials or those things which allows the flow of current to take place. We know that most of the things which are metallic can allow the flow of current to take place, and those things which are non-metallic do not allow current to take place. So let us learn some of the conductors. Those materials that allows the flow of electric current to take place through it, they are also called as good conductors or simply conductors. For example, silver, as you all know, it is used mostly as an for preparing ornaments, necklace, earrings, rings, and all. So this silver, as is also considered as one of the precious metal, it is always used for ornamental purposes. But in some places, this silver, in some parts of the world, people use this silver metal for the conduction of electrical energy. That means it is converted into electrical wires, silver wires. So this silver wire, why it is used as a conductor of electrical energy? Because this silver is considered as the best conductor of electrical energy. It can conduct electricity better than any other metals. Secondly, we get copper. Copper is again another metal which is also used as a conductor of electrical energy. Okay, other than silver, most of the people, they use this copper and aluminum wires for electrical conduction in their homes. Okay, why? Because this copper and aluminum are cheaper than silver wires. Nextly, the lead of the pencil that you find inside your pencil. Okay, this lead of the pencil is also considered as a good conductor of electrical energy. It can allow the flow of current to take place. We know that the lead of the pencil is a non-metal, but except this non-metal which is made of graphite, okay, which is made of graphite, no other non-metals can conduct electricity. But graphite is an exception which is found on the lead of a pencil, is made of carbon and is also considered as a conductor because it can allow the flow of current to take place to some extent. But they are not as good as the silver and copper as a conductor. Okay, but as they allow the flow of current to take place to some extent, they are also considered as conductors. So be careful. If you sharpen both ends of your pencil and by mistake if you put a pencil inside the holes of your switchboard, then what will happen? You may get a bad shock because this lead of the pencil is a good conductor of electricity. So be very careful. Sometimes it may happen that your younger brothers or sisters unknowingly they may use the pencil by putting it inside the holes of the switchboards. So they may get a bad shock. Sometimes one may die also. So always keep the switchboards out of reach of your younger brothers and sisters. Metals which does not conduct electricity at all. Such metals are called as insulators or bad conductors. For example, wood, plastic, rubber, paper, mica, all these are examples of bad conductors of electricity or simply insulators. We know that we use switches which are made of plastic. The wood is again an insulator which do not conduct electric current at all. So most of the electrical insulations, most of the electrical insulations like the covers of wires or the switches or the boards that we have in your homes as switchboard, okay, these are made of plastics or wood, and the electrical wires are mostly insulated with rubber or plastics and all. Why? Because it is a bad conductor. This is why we use such insulations in electrical appliances. Even you might have noticed the electrician using the plus or the tester having a handle with which is made of plastic and all. Okay, what is the importance of having the handles covered with plastic or wood or some other things which is an insulator? Because it will not allow electric current to pass through it. Okay, so we use electrical wires which are mostly made of copper. Now silver is a bad conductor, it is not used because it is too expensive. As it is too expensive, too costly, we don't use this silver as a electrical conductor. Mostly it is used for ornamental purposes. Aluminium is also used for making wires, switches, terminal plugs, filaments, and so on are some of the uses in electrical appliances. You may have already come across one use of carbon in the cells. As I have already told you that the cell has a simple representation inside it. Inside the cell we find a carbon rod. So this carbon rod which is found inside the cell, okay, is a conductor, we can say, which is made of graphite. Okay, is also a conductor. It is used in many other electrical devices as also, not only in the cells of or in batteries. Now talking about the insulators. Insulators we have learned these are the things which does not allow electric current to take place. These insulators, why they are always used in electrical appliances as tester or the pluses or as in electrical wires or in switches and all or in the switchboards. Why? Because these insulators they play a very important role in electrical circuits and equipments. In switches, an insulating material, plastic or metal, it separates the metal terminals from each other. Because of the insulation that is made in electrical appliances of switches and all, what happens is that it separates the metal terminals from each other and does not allow us to get any bad shock. The electric wires used in most circuits are either insulated by plastic or rubber cover or by a coat of insulating enamel. This insulation of wires, it ensures that an alternative circuit is not created in case the wires are touched by mistake. Sometimes it also prevents us from short circuit. By mistake, if we come in touch with the wires, then we may get a very bad shock. So mostly we find the insulations of wires are given with a rubber or a plastic. So as to prevent ourselves from a bad shock. Okay, so that we may not get harmed. Not only this, many other things that the electricians use as a tool, such as line testers, screwdrivers, pliers and all. Okay, these are insulated with plastic handles and all. Okay, to prevent us or to prevent the electricians from getting electric shocks and all. Okay, why it is always insulated? Because not only to prevent the electricians from getting a bad electric shock, but we know that our body is also a good conductor of electricity. So if we come in contact or come in touch with any of the electrical appliances at the time when the electric current is flowing through it by mistake, then we may die also, as our body is also a good conductor of electricity. Students, you all have understood, I guess. If you have any queries or doubts related to the chapter that I have discussed today, you can call me every night between 8 to 10. I shall try my best to clarify your doubts. So with this, my class gets over. Thank you. Have a nice day.